We're used to thinking about the distributive property in terms of multiplication and division, and we've used arrays to show that, particularly with multiplication. And we have here 9 times 37. And I've gone ahead and I've broken it up because I can do that with my distributive property. And I can break up the 30 into 30 plus 7. 9 times 30 is 270. 9 times 7 is 63. I add it all together, I get 333. Well, the same can be true when we have letters. We don't necessarily have to have the variable. We don't necessarily have to know what it means. We just have to know what it does. And we can use the distributive property to show, just like we did over here when we took these apart, and I can distribute it, and I can say, well, this is equal to, A times 1 is A, plus, well, now I'm going to have 2 times A plus 3A. I can also use the distributive property in other ways with when I already know my number. But I look at them and I say, what do they have in common? Well, they both share a factor of 2. And I can divide. Remember, whenever I do something, I have to do it. It has to be fair, and you have to do it to everybody. And I can say that a 6 is going to be, that's going to be 3A plus 5B when I divided them. But the original equation really was, it's going to equal 2 times 3A plus 5B. And even when you have something as I know, not everybody loves fractions, but they really are your friends, I promise. So when you've got something like 2/3 and you want to distribute, again, we're doing this, whatever we do to one, we do to another. I know that 3 is a factor of both 15 and 18, so I can divide both 15 by 3, and I get myself a 5. I divide 18 by 3, and I'm left with 2 times 5A. It's not 3, it's 6. All right. We're going to pretend I didn't make that mistake and say 5A minus 6. If I want to continue distributing, I could even go so far as to say 10A minus 12. And all of these are going to be equivalent to the first one. And that is how we use the distributive property with our variables.